but just setting it up, because there is a specific question, what do I replace dy dx with?
Okay.
Now, if I'm going to try to make this dE look a little more simplistic, and by the way, you guys, can I change this? Sorry. I'm not really changing the mathematics, but I called it y prime just so I matched the notation you're using on your computer.
Okay.
He's referring to this as dy dx. It means the same thing. So I think, just at a glance, it might be convenient to allow us a substitution of letting at this point. The ratio of y to x, just have an alternative name. You know, at minimum, on the right-hand side of the equal sign, I think it does indeed simplify its looks. So let's give it a shot. But to give it a shot means I think I've got to commit to the substitution. That means I've got to replace dy dx with something. So what I could do immediately is differentiate, excuse me, both sides to relate du to dx. I misspoke. To relate du dx to dy dx. I just don't want to because I don't want to use a quotient rule. So being as lazy as I am, I think what I'm going to do is take a quick break, get rid of fractions, and then try to force a relationship between du dx and dy dx. At least now I only have to use a product rule. So let's give it a shot. Keep in mind, you guys, keep in mind that if I were to solve a dE like this as is, then y is understood to be a dependent variable or dependent function in terms of the independent variable x. Well, if u is equal to y over x, then u is a dependent variable as well. It's a function x. So differentiating both sides with respect to x means on the left-hand side I got to use a product rule. And I get the second times the derivative of the first with respect to x, plus the first times the derivative of the second with respect to x. And I think on the right-hand side, here's what I get when I differentiate with respect to x. So Brad, number one, I will indeed replace every such ratio with a u. But number two, on the left-hand side, another name for dy dx is indeed the sum of these two beasts. And so now I'm left with an x du dx plus a u being equal to that stuff.
I see.
It really was just a commitment, or not a commitment, but a payment consequence of allowing u to be that ratio of y to x. Is that a little better?
Yeah. So you just did the product rule,
I did
differentiated with respect to x.
And keeping in
that's
mind
it.
that I did differentiate with respect to x.
It seems like that's something I probably should have got. All right.
Well, it's something I went through yesterday. But
Yeah, I know. I was just so tired when I got home last night.
oh, now come on, you're a new computer. Oh, it's my fault. Not a rubber. You're small. So you guys, give me some feedback. How was the quiz? You're laughing, Jason. Depends.
Can you set up number 2?
I'll do whatever you like.
I think a lot of people try to use L minus E instead of just K tan B.
Oh, I'm sorry. I don't know where the L minus P is. Where is it?
Second problem.
Second problem, it was a population growth, and people just, I think, I didn't do this, but some people, it was a logistics model.
Oh, so I said you assumed just as well.
No.
No, I didn't.
Yeah.
That's my point. You guys, I'm just stalling. So when I have to read it, you have to hear my voice on it. I'm just waiting for my computer to catch up. Oh, it's hot. Oh, how much fun. Somebody stayed on them. The habit we can create. I'm nice. I would never do that. Is this it?
Yes.
Wow, you guys, quiz 5, we're halfway through the semester. You only have 5 more to take.
Yeah, and we get one free one too, because.
Be quiet. So you guys, I'm being honest, it's been way too long. I really do have to read it. A culture of bacteria is subjected to a controlled environment in order to test a new growth inhibitor. Data from these tests provide and show a growth model that has the following condition. The rate of growth, oh shoot, I'll give that a name. Mathematical symbol, isn't that just the rate at which the population is changing with respect to time?
Yeah.
Is proportional to, don't read the rest. To say one thing's proportional to another means the first thing is equal to, I don't know, some constant times the other. And let's identify the other. The tangent function evaluated on the amount of bacteria present at time t. So I've got it proportional to the tangent of the population as a function in t. Look what I just done. I created a differential equation. And I think this will be a piece of cake to solve. I think just at a glance, the separation variables technique is what's going to apply. And so I maintain that I've got the integral of, I don't know, is that a cosine of p over sine of p? With respect to p being equal to this. And I maintain on the left-hand side, jeepers, if I just allow u to be the sine of p, its derivative sitting right upstairs, no sign change as a factor. And so I think all I'm really left with is the natural log of the absolute value of the sine of p. Or maybe in this example, you guys, this population, or p stands for this population at time t, and it's bacteria, you know it's not going to be negative. But I don't know how far p is going to go as an angle, so I better just be careful with the absolute values. And in solving for the sine of p, I think I'm left
So
with this.
you could just take the integral of cotangent of p too, right?
Absolutely the same thing.
Okay.
And so I think at the end, p is nothing more than the inverse sine of this product. Jeepers, was that quick? Yeah, it was bad. Now, of course, you got some boundary value conditions to put in there, and I've also expressed that this particular model doesn't go on indefinitely. I think it stops at.
Can you graph it?
Graph.
Do the graphing part, where it says sketch 2 graphs. Wasn't
I'm
it?
sorry, what two graphs?
Well, it says
So
in addition
P
sketch 2 graphs.
against P, so
Yeah.
that means I'm going to sketch against P my rate of change.
Oh, okay. Okay, never mind. That's just too easy.
I'm just going to look just like
I wasn't really sure what you meant by that. I thought you meant graph dp dt
so just a sinusoid.
and then graph p. Yeah, all right.
For this formula for exponential growth, when going about solving, or later subbing in for k, which form of the equation do we use?
Ooh, that's entirely up to you. It depends on where you want to go backwards. You can go all the way back here, find the constants k and c, and just manipulate. I'm so lazy, I go to the very bottom, just so I don't have to redo my algebra. Why are you squinting?
Isn't it tangent?
Yeah, I think I'm completely wrong.
Oh.
Think about it, watch. You guys treat this as an x. Treat this as y. I think it just got y equals some constant times a tangent of t. I'm gonna stall. Does k end up being positive? I have no idea.
Yeah.
Okay, it makes a difference when I actually draw the graph. I'll fix my clumsy mistake. I think graphically speaking, what I really meant to say is I got this. Horizontal p-axis. I think I've got a portion of a tangent wave. I need to slow down. Now I'm being honest. Now I really might make a mistake on my part. What did I say? Oh, but the population reaches 1.5 milligrams eventually, and after that the population remains at 1.5 milligrams. Like
So it
this?
just goes. Yeah.
No, I don't think so. I think I reach this population, and then once I reach a certain rate of change, or when the population reaches 1.5, I think the rate of change goes down to 0. Oh, I should use a different color, I'm sorry. That's true though, Mike, isn't it?
Yeah.
Okay.
Ow.
Yes.
So did we have to have the arrow going on the bottom one connected to the fill dot? Because if P stops at 1.5, wouldn't dP just be that dot?
You know what? I have no clue. If you interpret it this way, I'm just fine
No.
with that. I don't know which one more accurate.
I mean the arrow connected to the bottom part. P is just stopping at 1.5, but P doesn't keep growing. So when
My
it's-
apologies. I got your point. I didn't even catch that. That truly is my mistake. He's saying P's not increasing without bound. P reaches a value of 1.5 here. And then after that, the population remains at the value of 1.5. So I really should have marked this as 1.5, then drawn in my arrow. Or did you say you had a problem with the arrow?
Yeah, I'm saying a problem with the arrow because doesn't the arrow imply that P could keep growing, but P is.
My apologies. You know what? I really didn't see that. I don't know. Let me think about it for a minute. So population gets to 1.5, rate of change is increasing tangentially, and then when P becomes 1.5, you're right. That's my mistake. I guess it's been too long since I wrote this question. I think that looks better. And just stop. What about the other graph? I said graph P against T. So here's my T-axis. Here's my P-axis. You know, I did say that if you really wanted to use a technology for this, not that I found A and K yet, but help me with this. Is that positive as well? Okay, if it is, then I think I've got an inverse sine graph. What does that look like? Anybody?
Inverse sine.
Well, if this is what the sine wave looks like.
You have,
Negative 3.
yeah, and so you're gonna have it going along the top, yeah.
And again, do you guys mind if I don't unitize my axis carefully? But I think I'm going to increase in such a way that it's an inverse sine function, and then I'm going to level out with my population at 1.5. I'm a little sloppy, something like that.
Cool.
Did you guys want me to find the constants?
Sure.
If you do, it should be a piece of cake. Can I erase this picture though? And in erasing this picture, let's see what's happening.
So just a quick question really
Yes.
fast. So for the first problem, you just wanted to know what the concentration was at the time of overflow, right? Because I didn't really know what rate it was
I
going
have
to
no
overflow
idea.
out of the
I'll
top
look
or
for it in a
anything
minute.
like that at.
I'll
All right.
check it out. So I know that if the pi 6 milligrams bacteria is placed in a special environment, grows to something else, that implies P of 0 is equal to pi 6. But I also know that in 1 hour, it doubles. Sorry for my pens, you guys. You know what? I might have some. So I think taking this mathematical model down here, using the initial value condition, I'm simply going to stick pi 6 in for P. I am likewise going to stick 0 in for T, but that's just going to give me the inverse sine of, excuse me. Is that just an A? So A is going to be nothing more than sine of pi 6. Let me rewrite. I guess that means that P, as a function in time t, is going to be the inverse sine of my A value, which I found to be equal to 1/2 e to the kt, and I think I've got enough information to find that value for k. I'll use the second condition, and the second condition simply says my output is 0. When my input is positive 1, that just gives me a 1/2 e to the k. Check that out. Merely one equation and one unknown, name of the k, I can solve for it. Allow me. Does that give me a root 3 over 2 equal to 1/2 e to the k? So I guess k is merely the natural log of root 3. So I think in the end, all I really have is that v of t is equal to the inverse sine. Hey, you guys, what does that end up being? 1/2?
T to the 3 over G back.
Oh, root 3 over 2.
I'm just too tired. Is that 3 to the... I'm sorry, I'm so slow today. How many of you got that answer? Oh, jeepers. Yes, sir.
What if we just left it at ln square root of 3?
Oh, that's fine. Maybe it makes it okay. You might prefer ease. The beauty guys
Thank you.
that he said he wanted to differentiate by some piece of cake. See, guys, can I scroll up? Since Brad wants to look at that.
So, I know you're really busy, but would there be any way you could throw us some of these problems for practice? Because you often craft problems that are better than the book problems.
Can I cheat?
Yeah.
Can I have 5 minutes in the class? And can I just pull something from the past?
Yeah, definitely.
Because I'm sorry, no offense, I really completely out of time.
Okay.
I just can't. But if you give me 5 minutes in the class where I can pull some up or post them, I can
Okay.
do that. 5 minutes should be enough. So you guys, what happened here? You asked what the question really was, and I'm sorry, I don't remember. So
Well,
what is
yeah.
concentration when I actually reach overflow?
Because I didn't even know there was an overflow pipe at the top until I reached that point. But then I know nothing about the overflow pipe at the top, so I just figured it's just going to be at the time of overflow.
Yeah,
That's what you
all
want
I
to know? Okay.
Or maybe I did a poor job on phrasing this, because I write my own questions. Maybe you should consider a tank that sits out an open top, no
Okay.
overflow pipe.
Okay.
And I just want to know what the concentration was once the level reached the very top and started overflowing.
Okay.
That's all I really
Okay.
want.
Yeah, the wording was a bit off. If it isn't just like maximum capacity of a tank or something like that, it would have made a whole lot more sense.
I'm not the best. So this is a question.
So are you saying that algebra is a pollutant?
What's that?
Because algebraic acid is a pollutant. So is algebra a pollutant?
Depends who you ask.
Okay.
Many math B students will say yes, emphatically. It's Eliza. Bryce?
Oh, Elijah.
Elijah, I'm so sorry, Elijah. You go. Bryce. Bryce.
You know, it'd be great. Give this to some of the Math D students and cut off some of the questions and just ask, is this a pollutant?
I'm much more delicate with my math students. They run array more quickly than you do. Michael Gonzalez. Michael. Guys, I'm sorry, I'm still so bored. You won't. David. Kelly?
I encountered a math D question that made me cringe today.
You know what? I think
They asked for a range, and then they drew the graph, and the graph looked like this. And so you had your point, and they asked for the range. And so I'm like, well, how do you know there's no asymptote there? And
True.
it just made me cringe. I didn't like it. I was not happy with that problem.
Katrina?
But it just goes to infinity, and you're just supposed to know that.
I'm having a statistics problem.
Chris?
My statistics are cooperating.
Chris Gwen? Oh, sorry, Chris. Jeepers. I used to see you way over there at night. Daniel Norman. Chris Samelka? Chris? Igor? Nicholas? You guys, are we ready for Thursday?
I hope so.
Well, kind of.
Raise your hand if you're caught up in homework. Oh, man, that's
Almost.
a killer.
So how did you want number 2 phrased? I guess would be.
On this one?
Yeah. Can you just go over
Wait
number
till I
1 and
get it
number
in
2?
everybody's hands.
Okay.
I'm slower than you are. Oh, jeepers. Daniel Wheatley. Daniel. Roland? Roland. You guys again, thanks for your patience. And you guys help me, is this one online?
Yes.
Please number 4. Or
So both number 1 and number 2, wouldn't the equilibrium solution be x equals 0?
No, I'll show you why in a minute.
Okay.
Oh my god.
Do you guys agree that differential equation is already expressed in this form right here?
yes.
So question. Skip number 1, do you mind? Let's go to number 2 first. Question.
Okay.
About the point 3, 1, do you think that function's continuous?
No.
It's not continuous at y.
Well, when you plug x to 3 in for x, what happens? Shrug your shoulders, you don't care. But you do care what happens when you plug 1 in for y.
Yeah.
I think that function's undefined, therefore it's clearly not continuous at y equals 1. If it were, what would that suggest?
Well,
If at y equals 1, if this were continuous, what would that suggest?
So we have to check the partial.
Good, nothing yet.
So-
Got to check the partial aspect of y, see what happens.
can I get a little clarification on the
Yes.
existence uniqueness theorem? I thought that the existence uniqueness theorem didn't apply if f of xy was not continuous on all intervals.
No.
No? So
I
I'm
think what the
misinterpreting
existence
it?
uniqueness
All
theorem
right.
says is this. If both that function f and its partial with respect to y are continuous about that point,
Okay.
then not only does there exist a solution past through the point, but it's unique.
Okay.
Now, if one of those conditions, at least one of those conditions is not being met, then the existence uniqueness theorem says nothing. It's sort of like in Math 31, the alternating series test. Remember the alternating series test said, oh, the sum of -1 to the n times a to the n. If the limit a to the n equals 0, and the a sub n sequence is decreasing, the alternating series test says you converge. But if one of those conditions isn't being met, the alternating series test doesn't say anything. It's inconclusive.
So I shouldn't have put here is not unique. I should have just put does not exist.
Neither. You shouldn't say any of that. The answer to the question number 2 is that we cannot conclude anything. The existence uniqueness theorem does not say anything about the solutions past that point.
And just, we don't have to put a reason or anything. We just say
That is your reason. Your reason. Well, okay, good point.
okay.
You're right. Maybe I would have said the existence uniqueness theorem is inconclusive because my original function f is not continuous about question mark comma positive 1.
Okay.
That's what I would have said.
Okay.
I almost only left this as the only part of my answer, but I said, it doesn't exist at that point anyways, and I can have a solution that passes through that point.
Oh, easy. Because I think at the point 3, 1, it could be the case your solution has a vertical tangent line there. Or maybe something like this at that point. It doesn't mean I don't have a solution. What about going back to number 1? The equilibrium solutions at x equals 0, y equals 1. Which one? Which one of those is equilibrium solution?
One.
I think neither. I think neither. Because I think the equilibrium solution is going to be a function of the form y equals some constant that satisfies a dE. And when I say satisfies dE, I mean this. I mean, when I plug c in for y over here, I get the number 0. Another thing I'm plugging y gives me 0 over here. Number 2 is derivative is going to be equal to 0 because, well, it's a constant function. That's why it would satisfy the dE if it were an equilibrium solution. I don't think there is any such constant. I think if y equals 1 were an equilibrium solution, this would probably look like an inverted fraction.
So x equals 0, it has nothing to do with
It has nothing to do with an
at all.
equilibrium solution because it has to be in the form y equals some constant.
Okay.
See the difference?
Yes.
Can I give you an example where you do have one? What if I had this dE?
Or if you just replaced y with x.
Now I think I have 2 equilibrium solutions, one at y equals 1, the other one at y equals -2. What about x equals 0?
Doesn't
None of
matter.
the form, doesn't apply.
Okay.
as I recall, you guys, I just graded this yesterday. I think everything else turned out for the most part pretty decent.
Yeah, everything else is nice. It's good.
Well, you guys, today, do I get to play?
If you must.
If I must. Do you know, when you guys, remember the example we had last time? I wrote it down. I said, Jeepers, I can't find an integrating factor.
Jeepers.
One of you, I don't remember who, you looked at the board and said, no, you forgot to bring a term down. And it does work, but it was such a nice example.